Oh my, this can't be right. What are 6550 output tubes doing in a Fender Bassman amp? This amp is built for 6L6 GC output tubes, and this one has 6550s in it. So this amp has quite a story, and it's 53 years old. This is a 1967 Bassman transition with an AB165 circuit in it, and I will tell you where it came from and what I'm going to do to it. This video is an hour-and-a-half long, and that is just part one. So if this sounds interesting to you and you'd like to see a full uncut repair and rehab video, then this is the thing for you. Now I gotta tell you, you shouldn't work on vacuum tube amplifiers if you don't know what you're doing. They have high voltage in them, and they can kill you if you're not trained and experienced in what to do. So use this video as education on what's inside your amp and what it looks like and what an experienced technician would do to fix it. Don't consider it to be training on how to fix it or what you should do to your amp. So that said, put this video on pause, go grab yourself your favorite beverage and a bag of popcorn and settle in, because this is a feature-length film, and it's going to be a lot of fun, and we'll talk more in just a minute. So here's the first of a few boxes of parts for this thing. Some of these I've had around for a little bit, and some of them are brand new. So I'd like to get this amp back to the point where the chassis is not falling out of it. It's been that way since I've had it. And get it back to where it is working good electrically. So I'll get to the part here in a second and see what's on the inside of it. It should be interesting. So the only thing I've ever done to this amp, change the tubes in it and add a cord to it. We'll talk about where it came from in a few minutes, but this is my delivery shot. So, and what do we have inside? But a mostly pristine amplifier. In fact, as far as I know, there have been 2 resistors changed in this, and those are the screen resistors on the output tubes, and it's had a 3-prong cord put on it, and it's the only work that's been done to this thing since I've had it anyway. And I don't see any evidence of any other work ever being done to it. So I picked this amp up at a friend's house. I went over one day and just happened to notice in his trash can there was this amplifier. And it's like, what's that doing in there? He's like, oh, it burned up. It's no good. Smoke came out of it. It's no good. We're throwing it away. I said, well, do you mind if I have it? Maybe I'll work on it. I had some electronics training. Oh, look at there. There's a set of untouched original equipment capacitors, Mallory's, and I'll pull the tubes out here in a minute. And so I took this amp home and had to, actually it wasn't the screen resistors, I think it was the grid. No, it was the screen resistors. The 470s were burned up in it, and it didn't have a set of tubes in it. And so I found a drawing for it, and so notice that pin is cut off on that 6550, and it will talk about that in just a minute. But got the amp running. A friend of mine had a Marshall combo that ran on 6550s, believe it or not. And there are very few Marshall amps that run on 6550s. But he was going to retube it. He changed the tubes in it every year, which really is not very necessary. But he had a set of 6550s laying around, and I looked at the tube manual and thought, well, these are within the electrical specifications. You should be able to sub a 6550 for a 6L6 without any problems. I don't think I would put a 6L6 in for a 6550, but the one problem is that pin 1 is generally used as a tie point in a 6L6 point-to-point amp, and a 6550 actually has an internal connection, I believe, to ground inside the tube. And so the only mod that you need to do to a 6550 to get it to work in the amp, you actually need to mod the tube and not the amp. You just clip that pin 1 off, and it doesn't make any difference electrically to the tube, but that will keep it from grounding out anything that's tied to pin 1 on the socket in a 6L6 amp. So that's why that pin is clipped out of there. And I put those 6550s in, and the other tubes that came out of the preamp of that Marshall, you saw some of those were Marshall branded tubes, and they I got to tell you, this amp has sounded like $1,000,000. The audio that you heard at the beginning of this video is this amp from a recording session that a friend and I did back in '97, so which was a solid 10 or 12 years after I got this amp up and running. So but this amp has always sounded good, and it's just gotten to the point where it's 53 years old. It needs new caps, and it needs to be gone through. A lot of the resistors have changed values, and we'll go through the amp. So you see me pulling the capacitor board up here toward board, and there's probably a lot of people out there who've never seen this before, and it's kind of one of the reasons for what I want to do on this channel and how I want to do things, and one of the things that makes this video and this repair so long. But what I've decided to do, I mean, there are a ton of good channels out there for tube amps. I watch several of them, of course. Uncle Doug is my favorite, and D-Lab is good, and there are several others. But a lot of these guys are fixing amplifiers for other people. And when you do that, it changes the game a little bit. And this is my amplifier. And I want it, it's 53 years old, and I want it to work for another 53 years. And so I'm going to try, my goal here with repairs of this nature, and I got to tell you, I got about 5 or 6 amps sitting behind this one that need to have the same thing done to them. But my goal for all of these amps will be, when I decide to change something, I want to get as much of the old out as I can, right? And so not only are these capacitors 53 years old, but the leads that are actually used as the wiring for their connections are also 53 years old, and they might last another 53, I don't know. But since I have new capacitors, and I'm going to want to get these out, replace as much of the leads, and so I will not be snipping or doing a topside replacement. I'm going to pull as much of the metal out and as much of the solder out as I can possibly get. And my second order for this, I got another roll of solder wick. So, because there is a lot of solder to come out of this amp. That solder is 53 years old, and it was put in a long time ago with equipment that is different from what we have today. So you'll see me working on this, and it really makes this repair long, right? You couldn't make money repairing this amp for somebody else, but I'm not doing this to make money. I am doing this to make my amp as good as I can possibly get it. And so, and I also don't work on these a lot, so I'm not familiar with the construction and how it's put together and the circuit and just all sorts of stuff. And so I'm taking my time and try to do things right. And sometimes it takes 3 or 4 tries to figure something out when you have a problem, and you'll see that happen here quite a bit. But what I thought, how this channel can be different from the other amp channels that are out there is really kind of showing an end-to-end repair, right? Show the problems. I see so many techs will diagnose a problem. Well, here's the problem, and then either do time warp or just cut in and out really quick or whatever. And I tell you what, these things can be difficult to work on, and especially a turret board like this. This board is this is a lot of stuff. I'm having a problem right here with my soldering iron. So, and this is a Heiko 9, what is it, a 928 or something like this. I mean, this is a fantastic soldering iron. Best I have ever used, ever. And I've been working on stuff for 30-something years now. But this iron, the tip on it is just too small. I think I got a 1.6 millimeter tip on it. So in an order coming in the future, there will be, I think I bought a 2.4 tip for it. Same iron or same pencil, same heat, same everything, but it holds heat so much better. This stuff is really heavy. There's a lot of solder, so it is difficult to get to. I consider myself a pretty good skilled solderer, and I've done quite a bit of it, and this board right here is giving me some fits. So you can kind of watch me struggle with it and figure it out, and I will eventually change my strategy, and I will clip these caps out and then pull the leads out with wires. And some of it I'll leave in, and some of it I won't. But the idea is to come away with a something. There are the connections in here that will stay together for another 50 years. So. Looking at the cap here, this cap's actually in good shape. I've seen a lot of these get blistered. There are one of these caps that has a blister on it, but no leaking electrolyte. No, I don't know what kind of capacitance these have. It's probably terrible, but I don't really have the means to test them accurately. What's going in is a new F&T capacitor. So I sourced this stuff from Antique Radio Supply, where most everybody else gets tube components from, and I find the prices to be very reasonable. The quality of components they have is very good. Their shipping is good. Even during COVID here, I've been able to get material in. I think I've made 3 orders from them so far for this amplifier, and I keep running across parts that I should have changed, and we're about to see one right here. There's a resistor that sets between those two. Look at the schematic here. There is a 220K resistor that sets between these first 2 caps, and it had changed values, and it was just out of spec. And I thought I'd leave it in there, but then I have second thoughts, and so that's going to go on a lot in here. You see me test it right here. The that you can see that resistor hiding down in there, and so there are 2 of them. There's one between the next one too, I think. So you just barely see the tip of the meter there, but get it in the right range, and that resistor tests 252, and so that's not a little out of tolerance, it is way out of tolerance. And so what actual effect, I think if anything it would probably make your B plus high. I really want to get this amplifier running as close to the way it was designed as possible. This is not a tone issue, although if you have high B plus, you're running your tubes really hot. Your plate voltages are high, so this is a good chance to change these things and actually convert them over to metal oxide resistors, which are much higher precision and usually test right at the value they're rated at. So, and I think generally, I think this calls for 1 watt. So what you see coming out of there, or what you will see come out of there, are 1 watt resistors. I can put a 2 watt resistor back in there for about the same space, and it just makes sense to put a higher rated component in it. As less heat, and it's less apt to cause problems in the long run. So that's kind of my strategy for this amp and what I want to do to it. And so you see me fiddling around here. I just can't get enough heat in this joint. You've got to heat up a big brass ferrule and these giant leads that are on these capacitors, and all the solder, and you have a lot of things that sink the heat away from where you're trying to solder, and just makes it difficult. I've seen people, I'm sure you've seen those videos too, and where people have attacked these things with these giant, sometimes it'll be a big pencil with a big giant tip on it that looks like it's made for soldering line things like a lineman would use, or better yet, a Weller soldering gun. And so while you can get this job done with that, there are better ways. So and if you use a good flux and use the right amount of heat, then you can get these components back in or out as you want to. So this will be pretty painful to watch here for a little bit as I try to get this together. You can see there's not much in there. The inside of that's pretty clean. The outside of these fiber boards in this amp have some looks like mildew or some mold on them. So I told you the story of how I took this amplifier out of a trash can. My friend who used it, I'm not sure he ever owned the amplifier. The amplifier was a bass guitar amplifier for a high school marching band. And he was the bass player in that marching band. And I think when the amp blew up on him, he, probably told his people what had happened, and they told him to trash it or whatever. So felt really lucky that I saved this from the landfill. So, because it was certainly headed there, and it makes me sad to think of how much of this equipment was thrown away over the years, and how much of it, could have just been repaired. I mean, the only thing that this amp, he had pulled the tubes out of it. I would imagine what probably happened to this amp is one of the screen resistors went haywire and got too hot and burned up, and the tube probably red plated and burned the tube up, or the tube went bad and burned the resistor up. There's a couple of different things that can happen there, but it was a couple of resistors, 50 cents, and at the time, so I got this amp in about 1985, I think. Yeah, 85. I have actually signed, you'll see it here when I flip it over. It's one of these silly things you do when you're a kid. So in 1985, I was 18 years old. So, and I thought I was going to be the next Dumble. And so I started signing my amps when I would mod them. And of course, this amp wasn't even really modded, like I mentioned earlier. But just one of those funny things. So, but I actually dated it when I repaired this amp and got it working. And that's in 1986. So if you were just starting out wanting to learn how to repair equipment like this, there's some things to look at here, things that you need and things that you need to think about. I see a lot of people use solder suckers, and about the only truth in solder sucker is that it sucks. I've got one. In fact, I've got a couple of them. I've worn my finger out trying to get them to work, and to get solder out, and so I prefer solder wick. I think if you're wanting to be a top level solderer, you need to use wick, learn how to use it. The wick is clean and quick, and depending on the size that you use, you can load up a lot of solder and get it out of there pretty quick. This is not terribly efficient because there's a lot of solder here, and being really old solder, the fluxes that were used were different, and I just don't find that old solder wicks up very well. And so you'll see me adding, I've got a little, looks like a little syringe here of Amtech, but any good flux will do. But if you add just a drop of that flux onto your joint, that solder will suck right out of there, and will run up that wick 2 or 3 inches. You have to be careful with it that you don't burn your fingers. So, so you see me here trying to develop a new technique to do this. I think I'll get it figured out by the time I do the last one. But so again, another cap, original cap. See a little discoloration, but no blister. Probably would be a blister sometime soon. And I'm gonna probe on it a little bit to see if it's soft. It's really not. So now I will tell you, just a couple weeks ago. So I'm wanting to use this amp for a recording project, and it's needed some work though. The switches in it are noisy, and I'm going to replace those, and it needs a general, all the pots need to be cleaned, and the tube sockets need to be cleaned, and all this. And I've been wanting to rehab this amp, and the amp is to the point where I don't know that I'd really want to leave it on for a long period of time to just have those voltages running constantly against a lot of these components that are in the power supply. So I really wanted to recap this amp, and I got to tell you, I really struggled whether or not, let's see what this resistor test at. That's a 220 that tests at 250, so that one needs to be replaced as well. So, but I really struggled with what to do with this amp. This amp sounds so good with 2550s in it, or 6550s in it, I'm sorry. It sounds so good. I mean, this amp sounds good. This is a brilliant amp. I'm really reluctant to change any of the tone signal path in it, any of that stuff. And so I have never heard this amp with 6L6s in it. When I got it up and running, I got it up and running on 6550s. And so so here's a good practice. I'm going to interrupt myself for a moment. And I will do this, and I may put a scan of the drawing up when I'm done with it. But I will go through this. All these carbon resistors none of them are at spec. It's just a question of how much. The ones that are in the highly heated areas of the amplifier will be the farthest out, and so they really need to be changed. If one of those fails, it could take the whole amp out, and then you've got everything in this world can be repaired, but it is downtime, and it is expense, and it is trouble that you have to go through. But anyway, I really struggled as to whether or not to change this amp back to 6L6s, but I decided to go ahead and do it, and so I ordered those parts. I wanted to change the preamp tubes. I think those Marshall branded tubes are not terribly great to start with. I'm not sure. I mean, I like new old stock tubes, and I've got some around, but I bought a set of JJs for this, and we'll see how they work. This amp may end up getting its original tubes and its 6550s back, so, but we'll see. So, but I will be hearing it with 6L6s for the first time right here with you. So I intend to record that, and we'll see how it goes. So you can see there's a lot of solder in here, and it really takes a lot of wick to get it out of there. So checking my cap out, I'm going to measure my leads so I can get them bent in the right place. And because I want a neat install. One of the things you can tell when an amplifier's been worked on, whether or not it's been a hack job, and having all the labels up, having leads bent so that they fit correctly, are all what you want to do. There's an art to this, as well as science, and so I do think you want to make your repair look good. It doesn't make it sound any better, but it makes it look good. So, and you can tell that the person who worked on it at least was thoughtful enough to measure things out. You can see these are things that the Fender factory put in there 53 years ago, and they got them in there to get them in there. They weren't worried about how pretty it was or anything else, and so those components are just in there, And they've worked, so can't really fault their methods. So here's the good old-fashioned heat and poke it in, because I cannot get all the solder out of that. Oh, and every time you hear that beep, so when I pull this iron, it has a holder, and when I pull it out, if you're not familiar with Heiko irons, when you pull it out, it's got a sleep switch on it. So when I put the iron in the holder, it shuts the heat off, and it goes completely away. And when you pull it back out, you'll hear me pull this out, and then you'll hear that beep, and that is how fast this iron goes from, I think it idles at 200 Fahrenheit, and it's set, I think it's 700, so 700 or 750, I think that's right. And that's how fast this iron gets up to temperature. I mean, this is just a brilliant piece of equipment. So glad I bought it. If you're looking for something like this, I bought this one at a place called TE Equipment. So it's like teequipment.com. I will get a link to it and put it in the description. I found them to have the best price, and since then I've made several equipment orders from them, and everything has gotten here very timely. Shipping is reasonable, and they've had what I've wanted, so I'm very happy with them. They're not sponsored in any way. We probably will ever even know their name was mentioned in this video. And that's leaded solder that you see going back in there. I am not a fan of unleaded, as it were. So, but lead free. So, and especially where you have heat, anything that's heat cycling, taking the lead out of the solder causes it to not be very flexible, and as things heat up and cool down, obviously they expand and contract, and it causes the solder to crack and form little cracks over time, and eventually your joint just basically disintegrates, and will make a terrible connection, and you'll hear it, and it won't work, and everything else. So you want to make sure that you have lead in your solder. Just don't eat it. Now, that said, you see as I'm working on soldering things here, I'll go in a very precise order where I will get the iron on the joint, and then I will let it heat for a little bit, and that takes extra long because I have a lower heat well, and so the iron has to supply the power. And then once I do that, then I will try to do the work. And I see so many people who try to solder, create cold joints or solder blobs, because they get right in there on top of the iron and melt the solder on top of the iron and pull the iron away, and you've got a blob of solder that doesn't really connect to anything. So the real key to success in soldering anything, whether it's a copper pipe or a component to a PC board or a point-to-point amp, is getting the joint heated sufficiently. In PC work, this is tough because you'll burn your traces up if you leave it on too long, and you can also burn the components up. So here I'm using a little silicone pad. I'm trying really carefully not to burn my fingers, and so far I haven't. And what I need to do, this lead was left a little long, and what I need to do is heat it and push it up through the board pretty directly, and so I can't use my fingers to do that. So I had this little silicone pad that came with the iron that is really good for that, and we'll be able to see the detail here, but I will, and just push it right up through there so it's all level and looks good. And then once I get it moved, then I will go in and heat that joint and make sure that it's heated through and through, and the solder melts down through the bottom and all that to keep that going. So learning how to solder is it's as much an art as a science. And I think I mistakenly talked about 200 and 700 degrees Fahrenheit. That's Celsius, I believe, that this iron is set to. But I'm not sure. I should double check that before I finish this video. So I'm just trying to tidy things up here and get a good set of flush cut pliers. That set of that Exolite plier with the orange handle that you see there, that long nose plier, I bought when I was 18 or 19 years old. I've got a pair of side cuts too. They've been the best two hand tools that I've ever owned in my life. And Exolite tools have always been good. What you see, the flush cuts here, I think are Heiko. So and I'm pretty happy with them. We'll see how durable they are over time. So here I'm just kind of straightening some stuff up. I want right angles on my wires and kind of a nice look, and make everything even. You can see that the folks at Fender weren't so meticulous, and that's just me. So now I'm going to go back over here and touch up some of the top side of the board. This board ended up with a lot of two-sided work, and what I'm looking for, and I will put at the end of this a photograph up so you can see it in detail. But I'm looking for a particular look. A good solder joint has a look, and this is what you have to learn when you're soldering, especially heavy and even PC components. It has a properly heated solder connection will have this concave, almost like a fillet kind of look to it, rather than a ball. And so if you look up at the top of these Mallory capacitors that are left here, from left to right, if you just look at the one I'm working on right now, that joint's lasted for 53 years, but that's a ball of solder, which tells me that the joint wasn't heated enough or as much as it could have been. But then again, I'll give them a little credit here. Solder in 1967 was not the same as it is today, and it's not because of the tin and the lead. It's mostly because of the rosin that comes as a flux now. So, but I'm going to try to get this loosened up and get it to come out. Just can't get it out of there. So I need to get my clippers here and just take all these out and then get the leads out. So the capacitors form a heat sink, and they take heat away from the joint. The heat runs right up that lead into the capacitor and takes it away from my joint, which doesn't help me get things done. So I'll eventually clip them out of here. But back to the soldering, there's just a look. Your joint should be shiny. It shouldn't have any cracks in it. It should not look like a ball. When you see solder that looks like a ball, solder has surface tension just like water does. And so you know how you fill a glass up and create a meniscus over the edge of the top of it. That's all because of surface tension of the water. Solder is the same way, and it will create that surface tension over the joint and create that ball, which eventually, if you didn't get enough heat down into the joint, will eventually come apart, or your connection will become intermittent, or it will create heat. So things that aren't this is a power supply for a tube amplifier, and it's got a lot of voltage, a lot of current in it, and so things that aren't electrically connected very well create resistance, and resistance, when power runs through it, creates heat, and so that'll work to break the joint down as well. So you see when I put that flux on there, that solder runs right up that wick. And what flux does is it breaks the surface tension of the solder and causes it to flow. They call it wetting, and it causes the solder to flow into surfaces that it has an affinity for. The reason why wick is made out of copper is that solder has an affinity for copper and will flow to it, and will flow away from other materials into the copper. So, and if you put a little flux on there, it will do the same thing. So I'm fluxing these joints. I want to get as much solder out of here as I can. So you'll see, I dig in here, let's heat the joint, and I'm looking for a bubble or a piece of smoke, and then watch it run up that, fill that wick up immediately. And so I've filled probably two inches of that wick up almost right there, and just that quick. Always pull it out so you don't burn your fingers. Find out where it bends at and cut it right there, and go back for more. Now my wick is mostly, or my flux is mostly gone on that first joint, so I'll go back for the second one and see it run right up that wick. And this is the best way to desolder anything. Now for this particular board, this wick is so heavy that I can't get all the solder out. When I work on PC boards, my goal is to get all the solder out without burning up the trace. And believe me, I fixed enough traces that I've burned up to be a heavy incentive to stop doing that. So here I'm just going to go through the rest of these capacitors and get as much of the solder out of the joints as I can, and then I will go through and clip things out and get to replace. You can see it took me about 20 minutes to replace that first capacitor, and then a little quicker on the second one, and now I'm going to do all of these at once. Now the first two capacitors, and when I say first two, I'm talking about what you see here from left to right. The first two capacitors on this board, and this power supply board, or this filter board, is essentially the same as a super reverb as well. So those first two capacitors are actually installed reverse to each other, and then the rest of them are all the same. And you can tell the polarity of these capacitors. They have a rubber end, and then they have a metal end, and the metal end is the ground end, I believe. And so you got to make sure you get the first two in right, or you'll cause bad things to happen. But the rest of them can be kind of replaced. Well, I'm going to try to replace and get all of them out at once and put all the other ones back in at once. The cap all the way to the right is on the schematic way over in the in fact, it's not even the value of it's not written, and you have to go through and kind of deduce on the schematic where it's at. It's all the way over to the left side of the schematic, but it is the 16 microfarad capacitor that goes down and creates plate voltage for what I call V1, which is that first, it's supposed to be a 7025, but it's going to become a 12AX7 here shortly, what was an ECC 83. So getting these out here now, I'm going to show this one. One of these had a pretty good soft spot in it, but I can't remember which one it was. I'm showing it to the camera here, but this footage was corrupted, so I don't have that footage, but that capacitor looked pretty good, I think. I don't have an ESR meter. I will probably eventually try to test these and see what they test out at. A new multimeter's been on my list for a while, and I will probably try to get one that does some capacitance checking and figure out where these are. So I won't throw any of these components away that I'm taking out of this amplifier. Should this ever go to somebody who cares, not that I really do, but it'll have all the parts in it that have been replaced. And that's just kind of a standard practice when you're working on vintage equipment, especially for other people. And generally in electronics world, in general, I very early on, after I graduated from high school, I worked in the electronics industry and I did a lot of repair work. And this was back in the day when people still had televisions fixed and electronic components fixed, and today we just throw them away. But it was a standard practice. I can't tell you how many television sets I fixed over the years that had bad horizontal output transistors in them. And the customer would always get the television back with a little capacitor in a bag, and they would always ask, like, what is this for? And it's like, this is just the bad part. And some states, I think, required that you return the parts to it. My state did not, but it was just a good practice to always show the customer the things that you changed. And if you're getting something fixed, then you should ask to see the parts that were replaced. There is no shortage of trickery that goes on in this industry. So I think the little discoloration you're seeing there is just a kind of where wax is built up, or was a kind of a run when they dipped the capacitor, all, way before my time. So, but when they made it, so I also want to apologize for all this chattering you hear. I really wanted to use one of my DSLRs to film this, and so what you're hearing is this lens constantly hunting. I don't have the right autofocus lens on it, so I have since stopped to use that camera and have got an alternative where we won't have to hear that noise. So clip that guy out of there, and we'll get the next one out, and we'll go on from there. So I talked about the history of this amplifier and how it was a marching band amplifier, and I can't think of a worse service case for a piece of gear than that. I mean, this amp and a speaker, if you've ever seen it done at a high school marching band, was on a cart with like 200 feet of extension cord trailing behind it, and somebody pushing the cart and the bass player marching, in all their regalia, and playing this thing. And I just can't, I mean, most high school football fields then, of course they're not now, but then were grass fields, and they're bumpy, and they have a lot of shocks and jars, and I can't imagine the tube amp even making it to almost 20 years old before I got it. So it's certainly a testament to its manufacture and its durability. So, but since then, it has not seen as difficult a life. It only has been used occasionally. Did some recording with it back in the late 90s, which you've heard a little bit of. And it is, going to be just here. One of the things I like to do is record real stuff. I'm no technophobe. There's that little soft spot, and I'll probe around on that, but there was no hole in this. I don't know if that would eventually become a bubble or not, but yeah, I'm not afraid of technology, and I would use a Kemper all day long, but I have real guitar amps, and I have some pretty nice ones, and I think it's fun. One of the things that I really like to do is record things and see how good I can make it sound. And the the amp is a challenge, and not it's not done as much as it used to be. You know, we're getting into the era of music where everything is produced digitally, and it's clean. And man, I love the new modeling stuff that's out, but there is just something about a vacuum tube amplifier that I think the models sound good, but they're not exactly the same. And sometimes it takes a really good guitar player to bring that out in the amplifier, but boy, once you do, it is something else. Now you can see I've got all the other caps off this board, and I've kind of changed my tact a little bit here to check some things out. I want to try to figure out what I'm doing now is trying to figure out, there's a little diagonal resistor in here, and I'm trying to figure out where on the schematic this thing is. I do believe that is, we'll have to see when I test it here. I think I'm going to point it out. There's actually 3 resistors there. So, and here's fun. So I'm about halfway colorblind anyway, and trying to figure out the bands on a 53-year-old resistor that's been hotter than a firecracker is sometimes a little bit of a challenge. And so what I'm looking for is the right band here, making sure I don't know. I used to know these, but I don't know them anymore. And so I'm just trying to make sure I've got the right thing here. These one of those is a 4.7, and one of them is a 1K, and I believe the other one is a 27K. So we'll see this here in a minute if I'm right or wrong. This was done some time ago, and I'm doing this voiceover. This is kind of a decision on my part. I thought I would sit down and work on the amp so I could concentrate on working on the amp, and not worry about what I'm going to say. It's as you can hear, it's hard enough for me to improvise all this without a bunch of ohms and ahs. So hopefully I'll get better at that. But what I thought I would do is voice over this after I did the repair, and I'm sitting here watching the video and seeing what I can do and I'm just trying to figure this out, and it's going to take me a minute, but rest assured I will become certain where this resistor is. On a modern schematic, you have part numbers and R1 and R2, and you have so there's a diagram. The interesting thing is there is a diagram. So there are 2 things Fender gave us for this amplifier. They gave us a diagram and they gave us a schematic, and this board is not included on either one of those things. So actually it's not correct. The components of this board are included in the schematic, but this board is not included on the diagram. So you can't really tell what is what, and I'm having a real problem with this color band on here. I'm trying to make sure that I know where this thing's at, and I'm trying to make sure that I see where the wire's going. You can see there's a wire that comes in from the board, and there's a wire that goes back out, and so I will trace these down to figure out where they belong. And so and then I'm going to look back in the schematic, and do this. So here we go. Looks like I'm ready to take a measurement finally, and let's see what this is. So switch views here, and this is the 1K resistor, and so that is on the drawing down toward the bottom, or what we would call the B plus So after it comes through the choke, that runs across the bottom of the schematic. So and testing these others. Sorry, I was looking away and didn't see which one that was. But so I will write these in. So right here you see, here's the 1K. And I'll write its value in there. And it was not terribly bad. It's only 4 ohms out. So I will not replace this resistor. So this is the 4.7, and it is testing at 5120. And I do believe if that's supposed to be 5%, let me do a quick calculation here. Yeah, that is out of spec, and I do believe I sourced a new one to put in there, and so I'll change that. And I do believe this is the 27K. I think that's what this one is. So we'll see here in just a minute. Well, we've got to pause in the action here while I'm thinking. If you've made it this far, I appreciate you watching this. I don't really intend anybody to watch this whole video. This repair will end up being in a series of videos. The next ones will be shorter. I will see to that. So let's see if this is the 27. Yep, this is the 27K, and it tests 25.6, which is low. So I would expect this to be high. I will eventually try to make sure if I have a resistor that tests high, I'm not worried about it being in circuit because I know it's high. The problem is that if it tests low, then I could have some parallel resistance there somewhere, and you can see what I'm showing here is that 27K resistor upside down. But I didn't really see what might be causing parallel resistance in that, and that's the 16. And so we'll see. I may end up lifting a piece of that to double check that, or I'm not sure if I just decided to replace it or not. But there will be a part B on this board in another video. It will be a challenge to change those two 220K resistors that are in between those capacitors, and I really wished I'd done it while I had it out. So those will probably get clipped from the top side and pulled through the bottom side and then put back in that way. But what I don't want to do is get that. I can't really hit this board from the top. I can bend those over a little bit, and I'll have to reach in there with pliers and pull that out. So I miscalculated here. I'm showing this to you upside down, not realizing that I would flip this entire footage when I got it in the editor. So that's why I'm showing it to you upside down. I will make a mental note of that in the future. So just getting everything out here, getting it all ready to go back in. So like I was saying, I don't expect anybody to watch this whole video from end to end, but going through this entire repair, if somebody needed it as a reference, or if you just want to learn different parts of this or how it goes together, then it's really what this is for. The really nice thing about YouTube is that I don't really have a limit. I can put up, I didn't watch it, but I saw there was a posting for the 24 hours of Le Mans. It's like, it was a 25-hour video, so I really don't have any limits here. It doesn't cost me anything to post this other than the time that it takes to produce it, which is significant, but I will, that's on me. So But I thought it was just really important to show like all the stuff that I'm doing if you were wanting to learn, or if you were wanting to see how the repair actually gets done without it just being cut away. You know, here it's broke and here it's fixed, and that doesn't. I mean, it's great to see the troubleshooting of the amp, but there's quite a bit of skill that's involved in fixing this. So, and here's a skill all of its own: straightening axial leads on capacitors without breaking them off the cans. So these things are welded, so to speak. They're kind of spot welded or electrically welded to the case or to the internal parts that they're connected to. And I've broken many of them. That's why you always want to use high quality parts. So I was able to get through these, straighten them out, and rebend them without breaking any of them. But I've had to repair my share of components before I was able to repair whatever they go in, because you got to be careful handling leads. These are pretty heavy. Now I will tell you that these leads are not as heavy as the leads on the Mallory capacitors that come out of it. And it doesn't concern me electrically, but from a durability standpoint, you just always want to take care handling leads. You don't want to bend anything more than a couple of times, or you'll stress break it, and you'll create problems. I can't tell you how many times I've replaced a component, and by the time you get it in the circuit board, if it's difficult to work on, by the time you get it in the circuit board, it's just had enough, and you get it in there and it's broken and you got to take it back out, put a new part in it, or do something like that. So you see, I'm gonna try to I'm gonna try to heat all these up and get them all stuck in there pretty quickly, and I'll probably change these last 4 caps quicker than than I had changed the first one altogether. So, get some heat in my iron, heat the joint, and you see I got a fair amount of solder out of there, so that went in pretty quickly. And at this point, I'm just wanting to get it tacked in there. Once I get the part in there and get it stable, I will go back and heat the joint and put a lot of new solder in it. Figure out what to do with the leads where possible. So getting back to the technique of soldering, a lot of people solder things together and just use the solder as a connector. And the way I was taught, you always wanted to create a good physical connection first. So if you can imagine like wrapping a wire or crimping it or creating some sort of physical connection first, maybe put it under a screw or anything like that, and then solder it, you've got a durable joint that will withstand a lot of abuse. And so you saw me working on some of these other leads where I'm trying to wrap the new lead. Instead of just cutting it out, I want to add that lead to some of the metal that's already in there, and find a way to physically attach it. Now, it's pretty difficult to do in this type of construction, but you'll see me try to wrap these around the bottom, and I'll get my probe out and sneak underneath this. I'll get this in here a little more durable, get this joint set up a little more. We'll see. I'll probably make myself a liar. It's been a little while since I did this, and I may cut that off, or I may wrap it, but now I'm still trying to just get it at the right level. And I'd like to thread it underneath that existing lead there. Oh, this one actually goes the other way, so I'm sorry. This one bends over to the left, so it makes a connection, I believe. So we'll see where it goes here in just a second. So if you've got any thoughts about soldering, I'd be really interested to hear them in the comments, maybe things that that you find difficult about it, or things that have helped you, or equipment that you like to use, just as tips to other people that might read the comments. I think that would be cool to do. You see me now. You see me. You almost have to pretend you're a surgeon when you do work like this. And every time you see me clip something, you see me go directly for the piece of metal that I clip. Yeah, so this one goes this way. This one feeds in from a wire, so those are not connected to the left. So here I will reach up under here, fish that lead under there. Instead of just cutting it out, I'm going to add it to the metal that's already there. And it's not terribly pretty. But it is just more metal, and it's another connection point. Now I'll go in here and solder it, and it is. This will be a durable joint, and I will try to not cut new metal out. If I'm going to cut metal out, it's going to be the old metal. These leads were shorter than the Mallory leads, and so I can't cut all of the old stuff out. I need it to create the circuit still. So you see me go in here every time I clip something out. I will go in with those pair of pliers. You have to pretend you're a surgeon, and your job is to not leave any sponges in your patient. There have been more good repairs wrecked by solder drops or clipped leads or extraneous junk that gets left on a circuit board, and sometimes it doesn't create a problem until way after the customer has gotten the equipment back. And so as a rule, when I clip something out, you see this pile I'm creating over here just above my meter. That pile is going to get bigger and bigger and bigger, and those are all things that I'm clipping out. Don't ever clip out a bunch of stuff and leave it in a circuit or on a circuit board and think you'll go back and get it later, because you might miss some piece of it. When you clip one piece and it flies across the circuit board, go chase it down, get it out of there, and put it in your pile. And that way you will not leave any short circuits for your customer, or even for yourself. Like I said, this is my amplifier. It would cost $1 million to have somebody. Now it's an exaggeration, but I don't think I'm worth that much. But it would cost a lot of money to have somebody repair this amp or spend this much time on it. And so a tech you would hire to do this, you just wouldn't be able to afford it. So, but since this is my amp, I can put as much time into it as I want to. And this is the way I like to do things. So this amp will outlive me, and whoever gets this amp will have to work on it at some point, and or have it worked on, and it's kind of my legacy, right? I'm going up and down these leads here with my pliers with the serrated part of my I don't know what you call them. I really don't. But just trying to flatten the leads out without being too rough on them. So you always go in here, put your component up, measure it over. Everything is being installed here so that the part values face up, so that anybody who gets into this amplifier can read what the part values are without removing the part or without any difficulty, and that is just a best practice. So you always want to do that. So, but I will measure these out and bend them over, and that's how I get them to fit on the board. The 16 microfarad cap is a little shorter than the others, so, and it amazes me how much smaller these components are than the original equipment. The state of technology is just so much better than it used to be. It's interesting. A lot of people want to put Sprague Adams back in these amplifiers, and you can buy them, and they're expensive. They were at least twice and maybe 3 times as much as these capacitors, these F&Ts, and I've seen countless instances on the internet where people have taken them apart and they actually have a smaller capacitor in a bigger case just to make it look like it's more of the vintage component. And I'm okay with that, but at the end of the day, you know, you're going to replace these things, and it is what it is. I think the smaller components, putting a smaller component in another case actually concerns me because of heat buildup. You've just created a way to trap heat. These capacitors don't get terribly hot, but this whole amplifier does get hot, and so the more, and there's, as you can see, this has a cover on it, and so there's not a lot of airflow that moves through here, and you want heat to dissipate as well as you can. And another reason for adding metal into these leads, so you can have as much metal to carry heat away from the component as you can possibly get. So I'm just working the rest of the caps in here. Pretty much the same as we've been seeing. I use this little silicone spatula quite a bit to push my leads up in there. Try to heat this joint. I can tell you the next thing that we're going to work on this amplifier is the power supply board, the one that the other board that is not in the diagram, I think. Yes. Let me look at that real quick. I've got the diagram right here. Oh, so that board, actually that board is in the diagram. The little power supply board that has the 6 rectifiers on it, and the additional rectifier that goes for your negative bias. And I do believe I will replace every component on that board and redo that. And I've developed an additional technique along the way that I think you'll find interesting if you're interested in how to work on these turret boards. So, but you can see this roll of solder. This roll of solder was probably bought in 1989. So I had 2 or 3 of them. You just buy stuff when you're working in the business because you use a lot of it, and then you don't work in the business anymore, and this stuff sits around. And so I've been really wanting to get rid of this roll of solder because I feel like the flux in it has gone haywire. It's a rosin core solder, but the solder still works fine, and I can add flux if I need to. So but that's how old that is. You see the Philips ECG, and so any old techs that remember the ECG components that we used to get. So there used to be the RCA ones, and then there were ECG, and then there was another brand that was kind of cheap. I always liked ECG components, but felt they were pretty good quality. But all of that stuff's gone away. There really isn't any kind of a repair industry now for televisions or consumer electronics that does anything. And the only thing left over are people, like if you get a chance to watch a couple channels like X-Ray Tony B and D-Lab and Uncle Doug, of course, and there's is it Mr. Carlson's Lab, I think. These are great channels, and these guys are definitely working in what is quickly becoming a lost art, and that's one of the reasons for posting this. Honestly, it's so funny. I watch. I think is it X-Ray Tony, or maybe him or Mr. Carlisle. I think I've got that right. I'll have to look it up. Those guys, I think, are hams. And so I went to a vocational program in high school to learn electronics, and ultimately won the state championship in electronics, like a competition at the high school level, and got to compete at the state level, and got to compete at the national level. And it was quite an experience. But we were just, my instructor, rest in peace, was a great guy, but he was a ham. And I'll never forget his call sign, W9NNT. And he was a great guy. He knew so much about radio and television and how the signals sit on top of each other. And that program was 2 years long, my junior and senior year in high school, and I learned a ton. And digital electronics were starting to become a thing, and so I kind of delved into that area, and eventually led to a real love of tech for me that ended up in a lot of career in IT and software development, and then that has moved on to business, and then that has moved on to marketing. So. But I like to retain these skills, and so I like to work on this. You see me blowing the smoke out of my face, or you'll hear me puff every once in a while. See, I grab that lead so it doesn't fly away, because I know that thing will go somewhere and I'll never find it, and I won't be able to sleep at night because of it. So, because I don't want 400 volts going across it when I turn this amplifier on. There is a point, and just as another preview, when I flip this amp over and start looking at the top side of it, there's a solder ball that was left, that was dropped in between two wires, that was obviously done at the Fender factory when this amp was manufactured, and sat in there for 53 years and never managed to work its way through the cloth insulation for the wiring, thank goodness. But I'll show cleaning that up and pulling that thing out of there. And so I've seen countless instances of amplifiers that have had like unsoldered leads that have worked for years, and then eventually just corrode and stop working. So, but getting back to my electronics instructor, he was a ham, and I started studying for the test, but never became a ham. Got kind of interested in the digital side of things, and but he was a great guy, and he just knew everything about everything. And so when I learned electronics, we still had televisions that used high voltage CRT tubes, and so I had to be taught how to work around high voltage and how to probe for it. And I mean, there's 25 or 30,000 volts in a color television tube. We would repair these things. I can't tell you how many televisions I've replaced tubes in, picture tubes, and that's a complicated process. So it's a little misleading to think that you can just start working on this stuff without access to some real instruction like that, and it doesn't really exist anymore. The kind of electronics repair education that I got just doesn't exist, and it's kind of sad. It is becoming a lost art. So part of the reason why I'm putting this video up is hopefully someone will be able to learn something from it. And there are a ton of resources out on YouTube where you can learn how radio works and television and all this stuff, but a lot of it's obsolete. So everything's digital now, and I think for the better as far as television goes. So I'm not there yet on the amplifiers, but I tell you, the stuff that Kemper and Fractal are putting out, and even Line 6, the modeling is just incredible. So good stuff. So all right, I'm getting the last steely heart stabbed here, and we'll be able to put a bow on this thing here pretty soon, I think. So if you've got like an electronics background, I'm interested to know how you learned. Leave me a comment down below and share it with other people. This video is going to be around for a long time. And, you know, you never know. One of the things I do when I look at a YouTube video is look down through the comments and see. And sometimes you can learn as much from the comments as you can from the actual video. And I don't know that I would claim to be an expert in electronics at this point, but it's a hobby and it's an interest and a skill that I want to keep. I've got LCD TVs around here that I fix. When something breaks, I can't throw it away. I have to fix it. Washing machines, just everything. So, so I have a lot of fixed stuff. And proud of that. Same with my cars. So, anyway, I'm going to get this last thing braided in here a little bit and get it soldered up. And we'll go work on the top side of this board a little bit and see what's left to do. So, but a couple of these guys, and so when I listen to Uncle Doug talk about vacuum tubes and working on these amplifiers, he reminds me so much of my instructor. And he the way he talks about circuits and some of the language he uses is the old school language, like kilocycles and getters and things like that just tell you he's from a different era. And I think he has got a lot of experience working on antique radios and a lot of tube type equipment, because that's all there was prior to. I remember going with my dad to the drugstore to test tubes when you had a color TV, and when it quit working or wasn't working right, you dug the thing out and you took the tube. My dad wasn't an electronics guy, but you picked all the tubes out of it and you took them to the drugstore and you test. There was a tester right there, a giant one, and you tested your tubes, and you bought, if you had one that didn't test right, you bought a new one right there at the drugstore. And I remember doing this several times, and then as things went solid state in the 70s, that got different, and then you would take the TV to have it repaired at a shop, and those guys were all old tube guys who worked on that stuff. But eventually they all just went away, and now there's no place to really get anything fixed anymore. So a big reason for this channel is I love tube amps, and that's going to be a big part of this channel. But there's other stuff that I have in the queue to be fixed, and I just think it's important to document as much of this type of work as we can, all of us as a community, to do this. And so please, like, if you have insights, or you think I'm doing something wrong, or you could have a better idea, man, please, if it helps someone else or helps me, then please put it in the comments. I look forward to reading these comments and responding to as many as I can, and it helps me learn, and will also help the other people who eventually watch these. I mean, I don't know what my real expectations on people watching this video is, but if 10,000 people see it over the next several years, I'll probably be pretty happy. And that's 10,000 people that wouldn't have seen the way I work on stuff ever. So now I'm going through here and reheating and re-adding solder, and I'm going to get the bottom of the board fixed up, and then I'm going to flip it, and I'm going to work on the top of the board, because whenever I heat the bottom joint, it has a tendency to make the top joint kind of messy. And so what I want to do here is kind of get them both looking good and to the point where I think they're durable. And so I'm going to add flux, and I'm going to reheat, and I'm going to look for that look, that concave fillet kind of curved joint that kind of runs up the lead and tells you that it's going to last for a long time. So here I have a tough time with this solder syringe, and it really needs a spout on it, but I don't have one. So I'm going to dip in here with my probe and just put a little bit. Don't really need a lot of flux. So flux is, just so you know, flux can be pretty messy. It is really sticky, and it smells. And any kind of rosin, like if you climb rocks and you use rosin on your hands, it's to make them sticky, right? When you put rosin on a bow to drag across a violin string, you're trying to increase the friction of the horsehair, so it makes the string vibrate. And so rosin is a really sticky thing, and you always want to clean your circuit boards with a flux cleaner, because sometimes it can be a little bit corrosive or a little bit acidic, I think. And so you do want to clean it, and don't leave big globs of. One of the hallmarks of a quality repair is having it be cleaned after. And so since we've moved away from aerosols and solvents that use trichlorofluorocarbons, this job is not as easy as it used to be. And so you'll see a lot of fluxes that advertise that they can be cleaned with water, and I don't see very many of them that work that well. So I would normally put on a pair of nitrile gloves when I work on this stuff, and just didn't for whatever reason. And I'll tell you, it's not because of the lead. If you wash your hands, if you keep the lead out of your mouth, and don't put your fingers in your nose while you're working on electronic equipment, you don't really need to worry about the lead. Now, I wouldn't let my kid solder stuff with lead solder without a pair of gloves. But it's not the solder that I'm afraid of. It's not the lead. It's a good pair of nitrile gloves will keep the flux off your hands. It will give you just a split second longer before you get burnt with a soldering iron. And it will also, if you just accidentally get into some voltage, it will be an insulator for your fingers. But I don't know that I've ever had that save me from that. But I have had my fingers in electricity a few times, and it's something you learn pretty quickly. Funny story, in that electronics class that I was telling you about, we had a fellow who was, I don't think, probably at the top of the class, and he was working on a TV, and it was a solid state TV, but it had, the old televisions that had color picture tubes in them had a high voltage circuit in them and a flyback transformer. And they created somewhere between 20 and 30,000 volts of high voltage. It's what accelerates the beam of electrons down the tube so that it strikes the phosphor with enough energy to cause it to glow, to make it really super simple. And he was poking around in the back of this television with a screwdriver, which is something that you do. It's a valid technique. A lot of times, flyback transformers, so the horizontal frequency of a television is about 16,000 hertz, and it's audible, and it drives some people nuts. Now, I got news for you. The older you get, the less it bothers you. But I haven't heard that flyback transformer whine in a long time. But you would have a TV come in the people would say it's making a high-pitched noise and I can't stand it. And so you would poke around. A lot of times you would have to replace the flyback transformer because it wasn't potted right. But you would get in there and knock around on it with a screwdriver and see if it had a loose connection, or if the high tension wire that ran up to the picture tube was bad, or not connected very well, because anything could disturb that and cause it to whine and vibrate. And so I watched this guy from across the room, and I couldn't save him. He was poking around with the metal end of the screwdriver, which is a no-no to start with, but he had his fingers down on the shank of the screwdriver on the metal part. He'd have been fine if he had. Now you hear me laughing about this. This guy was okay, but he would have been fine if he had just held on to the handle because it was insulated. But he got in underneath that high tension lead and drew an arc out of that flyback transformer, and which went right in his arm. Fortunately, his other hand wasn't grounded. That's one thing you never want to do. You always, if this circuit were energized, you would only see one of my hands. Don't ever put two hands in an energized circuit, especially in a tube amplifier. The high voltage, there's enough high voltage there to it can run up your arms and directly across your heart, and it will interrupt the electrical signals that cause your heart to beat, and you will die from it. So that's kind of what electrocution is. But he got into this thing, drew an arc, and it physically knocked him down. And I laugh about it now. It was a very serious thing that should have been that he should have been more aware of, and probably should have been. I mean, high school kids should have been maybe a little better supervised, I guess. So he ended up being fine and lesson learned, and I don't think he ever stuck a screwdriver in the back of a television again. So, but it was a lesson for all of us in the class, and hopefully it's a lesson for you if you're hearing this story. I doubt that anybody who ever watches this video will ever be working on a high voltage television tube, but 400 volts, which is in this amp, is enough to cause the same problem. So here you see me, I'm just kind of probing around. I'm looking for ground in the right places and making sure that there's no ground that shouldn't be. So like I said earlier, all the grounds, all the tops of these caps all run to ground. So I'm all looking to make sure that the crimped in is on the right side. Electrolytic capacitors have a polarity, and if you install them backwards, they will blow up. And I was working on a Pioneer amplifier one day, and I thought the filter cap was bad. Had a couple of big 1,000 microfarad caps in it. Took one out, tested it. It wasn't the problem. I put it back in, and I put it back in backwards. And so then I turned the amp back on, and I've got my face over the amp, and I'm working on it and just probing around, looking for voltages and thing, and it vented right in my face, and just scared me to death. And it didn't hurt me. It didn't cause any kind of injury. This was a long time ago, and I'm still around. But electrolytic caps will vent on you, especially if they're in a power supply where there's a lot of voltage, because they can build up a lot of pressure when they get heat inside of them. And when you hook them up backwards, that's exactly what they do. They create a lot of gas. So remember that. But I'm not anywhere close to powering this amp up, and I'm just, to wrap up this part of the repair, I really want to make sure that I don't have any shorts to ground anywhere, and just double check my work and make sure everything's connected. So, as I said, a big preview. We're getting close to the end here. If anybody, I'll buy lunch for anybody who watches this whole video. Well, maybe not. I should take that back. But I appreciate you watching, and we're going to work on the power supply board next. And I can't wait. That video's been shot, and so I'll be putting it on here pretty soon. So in the meantime, take care and goodbye.